Gravitation. Gravitation. Basic forces in nature. Basic forces in nature. Depending on the relative strength and nature of the forces, they can be classified into four categories. 1. Gravitational forces. 1. Gravitational forces. 2. Electromagnetic forces. 3. Strong nuclear forces. 4. Weak nuclear forces. Like this, the entire forces present in nature can be classified: gravitational, electromagnetic, strong nuclear and weak nuclear. Like this, we classify them into four categories. Gravitational force. Gravitational force. This force acts between terrestrial bodies or celestial bodies. The same force is present between the bodies present on earth or the bodies present in the sky or celestial bodies. So between any two bodies the force acts, and this is a long range force. It acts over a large distance, but it is a very weak force. It is a very weak force. Terrestrial bodies, and this is a weak force, and this acts over a long distance, long range force. Electromagnetic and nuclear forces. Electromagnetic forces. Electromagnetic forces act between charged particles between magnetic fields, because electric current and magnetic field are interrelated. So the forces present between charges as well as magnetic fields, they come under electromagnetic forces. These forces, they are stronger than gravitational forces, so we call them as intermediate forces. Their magnitude is much greater than that of the gravitational force, hence we call them as intermediate forces. They are also long range forces. They act over long distances. Compared to nuclear forces, these forces, they are called as long range forces because they act over long distances. The relative strengths of the forces. The relative strengths of the forces can be explained using a tabular form. In this tabular form, we notice serial number, type of force, relative strength, range. We consider the gravitational force as one unit, and by comparing the other forces with this force, we try to have an idea of the other forces, the magnitudes of the other forces. We consider the gravitational force magnitude is say 1. Its nature is long range and infinite. The range is infinite. The long range means the distance between the particles can be infinite. Over a long distance they act. And weak nuclear force, next to higher stronger force is weak nuclear force. It is about 10 to the power of 11 times the gravitational force. Weak nuclear forces are about 10 to the power of 11 times the gravitational forces, and they are extremely short range. They act over distances less than 1 Fermi. Third, electromagnetic forces. They are about 10 to the power of 36 times stronger than gravitational forces. About 10 to the power of 36 times stronger than the gravitational forces. They are also long range forces. They can act up to infinite distances. 4. Strong nuclear forces. Their magnitude is about 10 to the power of 38 times. It is about 10 to the power of 38 times the magnitude of gravitational force, and these are short range force. They act over a distance of over 1 Fermi. Gravitational forces are the weakest, and these gravitational forces become very predominant, very large forces between celestial bodies because they are very massive. The sun is the biggest body in solar system, and because of the large size, and the force between sun and earth is very large. Like this, we notice higher magnitudes of forces, gravitational forces, though they are considered to be weak forces. When we consider two bodies like 1 kg masses, therefore the force between them is very small, but between the biggest bodies, the largest bodies, the force is predominant. And these forces, using these forces, gravitational forces, we explain why an apple is falling to the earth, why moon is rotating around the earth, why the ocean tides are present, etc. We can explain certain natural phenomena with these forces. These forces, they are communicated. Gravitational force is an attractive force. Gravitational force is an attractive force, and it is believed to be communicated by a particle, field particle called graviton. It is assumed to be communicated by a particle called graviton. Electromagnetic forces are predominant at atomic level. They can explain why the electrons are revolving around the nucleus, the formation of a molecule, how the substance is formed. Like such concepts can be explained by these forces, electromagnetic forces. And they can also explain certain other phenomena like resistance, friction, air resistance, elasticity, tension, etc. These phenomena can also be explained using electromagnetic forces. These electromagnetic forces are both attractive and repulsive. They are repulsive between like charges and attractive between unlike charges. So they are both repulsive as well as attractive, and they are long range forces. They are believed to be communicated by a particle called photon. They are believed to be communicated by a particle called photon. Strong nuclear forces are responsible for holding the neutrons and protons together in the nucleus. These forces are responsible for holding the protons and neutrons together in the nucleus. These forces act between two protons, between two neutrons, between a proton and a neutron. The same magnitude of force acts between two protons, two neutrons, between a proton and a neutron. These forces, they are short range and very strong forces. They are believed to be exchanged by a particle called pi meson. When the distance is very small, they may become repulsive forces, and these are communicated by the particle pi meson. Weak nuclear forces are present between nucleons. This force can explain the phenomena like radioactivity, like beta decay, that is electrons coming out of the nucleus, and there are certain particles which decay. Such decay processes can also be explained with these forces. These forces are present between leptons and hardons. These forces are believed to be communicated by a particle called boson. These forces are believed to be communicated by particles like bosons. Though we notice different kinds of forces in nature, so far we know the forces are of different kinds, but scientific effort, that is research, is going on to combine all the forces and find a new theory which can be used to explain all the forces, known as unified field theory, that is going to explain all the phenomena together. And research is going on to find a new theory which can explain all the forces present in nature.